Okay, so in this demo here, we're going to be looking at determining the specific heat of a metal. I've already dropped an unknown metal bar here inside a beaker of boiling water. This is in hopes of bringing the initial temperature as close to boiling, 100 degrees, as possible. The mass was measured earlier to be 96.61, plus or minus 0.01 grams. We're going to be taking this really hot metal bar here and dropping it into a metal calorimeter. This metal calorimeter here has two portions. It is an inner metal beaker that's floating inside this outer metal vessel as well. There's a sort of a wall of air that's surrounding the outsides here. Air is a nice insulator, so hopefully any of the heat transfer from the metal bar that's happening inside this inner vessel is going to be soaked up by the water that I placed in here. Currently there's 100 milliliters sitting there. The thermometer is currently reading here 20.5 plus minus 0.5 degrees. Obviously the metal object here is going to lose its heat here. I'm hoping the water inside this metal vessel is going to soak up some of that temperature change. We're going to see what the final temperature heats up to, and therefore be able to use calorimetry to figure out the enthalpy change. Okay, so that's our setup here. I'm just going to prop the thermometer up just for a second here. We're going to take our really hot metal bar. Just be careful with this one here. Okay, it's going to be as close to 100 degrees as possible, and then we're just going to drop it very carefully here into this metal vessel as quickly as we can here. We're going to be putting the lid on top, trying to insulate it from the surroundings here, and then prop the thermometer in, hopefully to get a sense of what the temperature is going to change. Okay. You do want to make sure that the thermometer isn't actually touching either the metal bar or the bottom of the container here. Hopefully what's happening here is the hot metal object is now transferring its heat to the water that was inside the inner vessel. We're going to try to track what the temperature change is, then we can use our formulas, convert it to joules using our heat formula, and then eventually calculate the enthalpy change. So if you guys look close enough here, I'm already seeing the temperature changing. Okay, so we're roughly at about 26 degrees here and climbing. Again, we're trying to just sort of insulate this from the surroundings to make sure as little heat loss to the surroundings as possible, although we do need to make sure we have a hole on top so that way we can secure the thermometer in the container. So I'm just going to let this go for a little bit here, get a sense of how hot this can get. Obviously, you would need to know how much of a metal object that we started with here, but that should give us enough value so we can actually calculate the specific heat eventually. Q is equal to mc delta T. So it looks like the temperature is steadied out there. Looking at the thermometer, it's currently reading 26.0 plus minus 0.5. Thanks everyone.